Thanks everyone. I'm Brandt Technology-Futurist at Autodesk. And today we're going to be talking about 3D printing or additive manufacturing. And I'm going to give a bit of a preface before we bring the panel up. To contextualize this, we're going to assume that everyone in the room is at least roughly familiar with the idea and some of the technology behind additive. But the picture we wanted to paint was its potential impact and positive environmental impact on global supply chains. If you think about the way everything today, but in 10 years, it's going to be drastically different space. So here's a very quick story of one of our clean tech partners. We have a program where we sponsor, I think you guys have heard a lot about some of the partners who are with us today. This was an electric vehicle manufacturer. We'll release this case study later, but basically we're helping them to design and 3D print the final product. This is actually going to go onto their electric vehicle. So we're redesigning it to make it lighter weight, to embed carbon fiber into it. Is about design. So at the end of the day, we're a design technology company. So really likes to make things. And how does this change the way that we design? Traditionally, we have engineers sitting down and doing explicit design. You need to draw a shape, they extrude it into 3 dimensions, maybe they make some holes in that. But it's a human sitting down and literally drawing that shape. The future we're going to get into is where we set the constraints to the design software. This is what you need to attach to, this is what the load will be, and the computer goes through billions of permutations of designs to find the optimal. This is an example of a private space company that's sending a lunar lander next year. And this is the part, it's a thruster bracket. So it's simply a bracket that attaches to the fuselage, holds the thrusters in place. Now, I don't think a human would probably come up with that design and assume that it's optimal, but it beat all the human designs by a large percentage. So this is indicative of where we're going. I wanted to bring the panel up here so we can have this conversation with everyone. And, hold on guys. And we'll introduce everyone. About 6 millimeters long. So I went to the hardware store and was faced with this. Thousands of varieties in a little piece with different thread counts and different dimensions. And of course, the one piece that I needed, it wasn't there. So here this hardware store has shipped and inventoried thousands of parts, but as a customer I got zero value out of it because they didn't have what I needed. This is going to seem as antiquated as steam engines in about a decade. We're going to be able to produce this on demand right where we need it. Think of something like Barbie. Now we can chuckle, but I found in this research Barbie is a $2 billion market unto herself. Barbie is typically packaged and shipped in these big boxes, which look really nice on a retail store shelf. Now Barbie herself has about 200 grams of plastic in it. So do the math. One shipping container can fit about 12 to 13,000 boxes. That's pretty optimistic. But if you ship the equivalent of the raw material, you've got 250,000 Barbies in that same container. Screws, all those screws. But imagine a world in which you place all the components by a robot onto the phone frame, and then a printer prints conductive ink on top of that to connect those pieces. And the printer prints a customized enclosure on top of that phone for a specific audience, or a specific user. Right? It's going to augment and enhance existing processes, not totally replace it. Now there's machines coming on the market, this is really exciting. Industrial equipment manufacturers who've been around for decades, providing for the aerospace and automotive and industrial industries. They're now getting involved in additive manufacturing. They haven't been sitting on the sidelines and watching the new startups without thinking, what are the applications that we could use? What you're seeing here is laser clad, so it's actually spraying metal powder and additively building this layer by layer. But what's really cool about it, I mean that alone is pretty cool, but it also integrates machining. So the same tool, the same device, is now giving precision machining to this turbine blade, all in one. You've got an entire factory to be able to produce highly complex metal parts in one box. Now right now it's a pretty expensive box, and it's fairly complicated to use, but that's why we're partnering with guys like these to make it accessible. Again, this is all about the democratization of new technologies. So now what can you do with this? Where would you put this?
So what we're seeing is much more of a pull for mass customized product. Saying mass customized, you touched on it with
expect this market to emerge local and get designed, Canal turbine blade is a very, very expensive piece to manufacture. And you get
Tech partners, and we've had access to modeling software, the computational tools, dynamics software, and